if we're trying to write the equation that would give us these zeros, we need to understand the relationship between a zero and the factor. So if negative 3/2 was a zero, that had to have come from the factor x plus 3/2, because negative 3/2 plus 3/2 would be 0. So therefore, we know that this would be a factor that created this solution. If you have an imaginary, we had a theorem that said if you ever have an imaginary, you also have the conjugate of that imaginary. So 2i being one solution means that negative 2i is another solution. So when we write this factor, we're going to notice it's actually a quadratic because quadratics have two solutions. So the way that we figure out the factor that gave us the imaginaries is we set that imaginary equal to x, and then we're going to get rid of the imaginary algebraically. So if I want this I to go away, because in an equation we don't see imaginaries, so we're not going to write this as x minus 2i as a factor. We don't have imaginary factors like that. So what we do is we say, we know that 2i equals x, which means if I square both sides, well, 2i squared would be negative 4 equals x squared. And by squaring both sides, we've now eliminated that imaginary. So if I want to write this as a factor, I'm going to set it equal to 0, and then whatever that expression is, that would be the factor. So I can add 4 to both sides here. 0 equals x squared plus 4. Since this equals 0, x squared plus 4 is the factor that would give us these two solutions. Okay, so now, just for the sake of the exercise, I'm going to put this into standard form just so we can see that. So standard form, we're going to multiply this all together and we'll get our standard form. So that'd be x cubed plus 4x plus 3/2 x squared plus 6. 3/2 times 4 is 6. Then just to put it in the correct order, we want our exponents in descending order. X cubed plus 3/2 x squared plus 4x plus 6. What I'm circling now would be the standard form version of this factored form equation. Same equation in different forms.